All right, so welcome back to day 2 of college algebra for this semester. And so we're going to pick up where we left off on Monday, but I wanted to show you a couple of simple things first. This is back on the Blackboard page, so I had already showed you the Blackboard page on Monday, and so it hasn't changed really, but remember, on the Blackboard page, you can find the class notes, right, and the videos. So if you click on that link in the Blackboard page, so you can do this on your phone also, and there are the postings from last time. So there's the notes, the printed notes from last time that we made, and we're going to continue working from those notes today before we switch to a new set. So that's the first set of notes. And then this is in PDF format, so it's pretty easy to open anywhere. And then there's the lecture, and that's just a link to a YouTube video, so that also is pretty easy to look at anywhere. So that's the whole thing, all right, just taped raw. It's not edited in any way. So remember, sometimes we're doing class activities, so there's some dead space, right, in the video, and but you can move backwards and forwards through that if you want to review anything there. So for those new people, you may want to take a look at the tape of what happened last time, right? So you won't feel like you're behind it all, okay? But we're going to pick up where we left off last time, so so you'll probably be able to catch up pretty easily. We're mostly reviewing things that you know, but may need a little bit of review of, right? Okay. All right. So there is something currently now on something new other than the syllabus now currently on the Blackboard page, right? Okay. All right. So now another thing that of course is pressing on us is getting enrolled in the MyMathLab section. So remember, I gave you the instructions on a printed sheet, right, for the MyMathLab. So and that works, I think, okay. Those printed instructions. Some people are in, well, about 10 at least, but maybe more already are on the have gotten enrolled in the class. There's the instructions that I gave you, right? Okay, and so if you're new to MyMathLab, right, you're going to have to create an account, which basically is just usually what you do when you create an account online, right? So you have to make up a username and a password, and then answer some security questions, right, in case you forget your username or your password. Remember now, the electronic copy of the book is in MyMathLab, right? Okay, so that is embedded in MyMathLab. There's the copy of the textbook there. Maybe I'll open that in just a second here. I don't think we opened that last time. But we don't really refer to the textbook all that much, so you probably won't be looking at the textbook too much, but you might through the course. Most of the material that we'll be learning from, most of the content will be in my notes, okay? Some of which is drawn from the book and some of which is different from the book. So, but anyway, there is an e-copy of the book, right? If you want to buy a hard copy of the book, as I mentioned last time, you can do that in the bookstore. Okay, you can do that in the bookstore, and it should come with a MyMathLab access code. That's part of the price of the book, the hard copy of the book. Okay, so if you buy the book online, that is sometimes an issue because you have to make sure you get the MyMathLab access code with that, right? Okay, because this is really what's important. The textbook is not the important thing. It's the access to the MyMathLab that's the important thing for this course, right? So if you purchase the textbook online, you've got to make sure you get the access code. Otherwise, you'll end up purchasing the textbook and the access code separately, and it will end up costing you more money, okay? But if you just purchase the access online, you get the e-copy of the book. It's around $66 now, plus some change. But remember now, you don't have to have the money available immediately because you get a grace period here. So you can go ahead and enroll in the course, so there's no reason for people not to be enrolled in the course already, okay? And you can start working on your homework. So this is really important. I got everybody enrolled, and I've got to get everybody working on their homework. This is not a class where you're not going to be able to do the homework. I got to stress that, okay? The homework is absolutely vital, all right? So if you're thinking, I can skate by without doing the homework, if that's in the back of your mind, I know you're probably not explicitly thinking that, but if that's sort of what your habit has been in your math classes and you sort of fall back on that habit, that's not going to work, right? Okay, so you need to get on there as soon as possible. Now, having said that, though, okay, remember you need this. The only thing you really need to get enrolled is at least immediately, right, is this course ID. So they are going to ask you for that. Yeah, does someone have their hand? Yeah.
So I was asking, so it's not mandatory for us to get the hard copy, right?
No.
You just want us to get the code mainly.
Yeah, because you have a copy of the book inside MyMathLab. There's an ebook in there. I'll show it to you.
Okay.
Yeah, okay, yeah, it's there. All right. So you don't need a hard copy of the book. And we're not going to use a hard copy of the book. I don't even have one currently right now. I'll probably get one. I may show up with it from time to time in class, but I won't be referring to it hardly at all. I won't say, look on page X or read page Y, right? Won't do that, yeah.
So on the bookstore online, when you see the books, it has two options.
Mm-hmm.
Do you know which one it is?
That's a good question. So it is, I think the name of this book is College Algebra with Modeling and Visualization, but maybe those are the same book. Did you go to my section? Did it give you that option? Oh, yeah, this is my section. This says MyMathLab standalone, so maybe that's just the access code without the textbook. So that's probably cheaper. So look at the price, and that's all that you would need. So if you buy that, they'll probably just give you like a piece of cardboard with the access code on it, not the book, right? Okay. I suspect that what is, but look at does it tell you what the price is?
I can look it up.
The cheaper one is probably just the access code, which you could also purchase online. But if you want to get it through the bookstore because of financial aid or something, right? Does it say the price?
I don't think so.
Well, that says $209, so that one we
yeah.
probably want to avoid, okay? Because that sounds expensive to me. And that one's still pretty expensive, $141, but that's probably just the access code. Wow. But I think you can get it for just $66. So if you go.
Is the code at the bookstore here?
No, through online. Apparently at the bookstore it's going to be $141, right? Okay?
Yeah.
Just the code. Yeah. All right.
Yeah.
But if you need to do that, if you need to purchase at the bookstore for financial aid reasons, then of course you can do that, right? Okay. But online it's going to be cheaper, right? Directly online. All right. Now, however, so remember that you need, right, that Waller, whatever those digits are, correct? Okay. So let me switch back to the laptop here for a minute. So if you, so remember, you go here, you go to register now, you choose student, right? We showed this last time. Don't worry about the browser messages. They usually are not meaningful. I would work in Chrome if possible. If you're working in Safari off of your phone, for instance, or an iPad, for instance, it sometimes gives you a message like this one, but I haven't noticed really any issues. So I would just say, continue without, updating the browser. I'm going to deal with that. Okay, and then so you have to have an email address, right? So remember I told you use the email address that you actually check, right? Because I'm going to send you messages to that email address, and I want you to get those messages. So if you don't check GatorMail, do not use GatorMail here, right? And then you need that course ID, right, that I was just telling you about, all right? And then it says you need to pay, but again, you don't need to pay immediately, right? What was that course ID? So it was Waller something. Waller 2... Say that again. 2785.3, okay, and then just hit continue. And for most of you, so it found me, right? So that's the right course. And then for most of you, you're going to create your account for the first time, right? So that's, but if you just have happened to have used MyMathLab in the past, you can go ahead and sign in with your prior username and password, right? So if you remember that you have used MyMathLab, then and you have an account already, hopefully you'll remember the username and password, then you can sign in with that, okay? Of course, once you've created the account, right, then from then on, it's just a matter of signing in. You're not going to register twice, right? Please do not register twice in my course, because that causes issues in my grade book. And of course, now when you create the account, you're going to have to, type in all this information, right? That's typical for creating an account online. And then just go ahead and create the account, right? And then it's going to ask you to pay, all right? I'm not going to create a dummy account here, but at that point, it's going to ask you to pay, but you do not have to pay. Look at the bottom, and it'll say continue registering with a grace period. There's a little line there. They've got it hidden because they want to force you to pay, right? Okay, but there is a line at the bottom that says you can use the grace period. So go ahead and click on that option if you want to. If you want to pay, great, right? Now, but otherwise, go ahead and click on that, and then we can worry about paying later. Okay, so if you do it online, you'll need again a credit card or a PayPal account. But if you purchase the access code from the bookstore, you can just type in whatever the access code is at that time. Okay. All right. So it may be a few glitches there in getting registered, but you'll be able to pull it off there, okay? If you're having issues with that, let me know, okay? On Monday, I'm hoping to bring some iPads to class so that we can practice our homework a little maybe on Monday or Wednesday of next week. I'd like you to be enrolled by then, okay? So take the time to enroll. You can do this on your phone, if not, by Monday, we're definitely going to get enrolled, okay, because we've got homework coming up. All right, let me see if I can backtrack here now and actually see what things look like once you've gotten registered. So let me go ahead and sign in as myself. So, of course, my view is going to be a little bit different from yours, but let's try let me try the student view here. I think it gives me an option for looking at that. There it goes. So I think this would be more or less what you would see, right? Okay, something like this. And that includes, right, notice your overall score. So your score will always be up to date there, okay, if I get my grade book set up correctly. I hope I have. So you will always know what your current average is, right, okay, throughout the course. So you'll have an idea of what grade you're headed for, right, throughout the course. Now, we do have some stuff due, right, okay? So there are some homework assignments posted. And the first one there is an orientation assignment. That is just practice in how you enter answers and how you use MyMathLab, right? So there's no real content there. There's no math content. It's just very short. It's like, and even it's not very helpful, actually, because I went through it, and it really doesn't help you that much in how to enter answers. But so that's a easy gimme grade there, right, for you. Just that orientation assignment of how to move around in the assignments, how to type in answers and things like that, okay? You probably, that orientation is not enough. Probably we'll have to talk a little bit more in class about how to enter answers, or you'll have questions about that from time to time. And there is but that's the first homework assignment, okay? That's the first real math content homework assignment. What day is that due? September 4th. So you still have a little bit of time, right? Okay. But I want to get busy and work on that. You are ready to start that already based on our discussion on Monday, okay? The algebra review I've already got posted, but notice that is not due until September 25th. That's the day of the first test, remember, in the syllabus. So this is an extra credit assignment, and this is to review some skills from algebra, some of which we're reviewing here in class, but not all of our algebra skills we'll review explicitly in class. So I've got that for you. You can work on this a little bit at a time, okay? And if you get a high enough score on that, then you will get extra credit. So I'll discuss what extra credit you will get for that, okay? I haven't decided on that yet. So you can work on this a little bit at a time because it's not due until September 25th, right? But there'll be other assignments before September 25th. I've just went ahead and posted that. Ooh, let's open that first homework. I'm curious to see what's in there. Have y'all started that one? Anybody started that one? Not the orientation assignment, okay? But the first homework assignment, okay? All right, so there they are. It's not very long, right? It's only 12 questions, 13 questions, so it's only 13 questions. I think they're all worth the same, approximately, okay? And, well, they are. There it says, 7 or 8 points, right? And so that should add up to 100 if I counted right. So I think you'll see the very first question there. Just click on that, right? Okay? And so easy, right? Okay? You just have to type in there. Just simplify there a couple of powers, right? Okay? So are those two things equal? Are those two things equal? Yeah, 2 to the 4th and 4 squared, right? Okay. They both turn out to be what? 16? Okay. So so you can just type in here 16, and I think you get a. This is going to be tough for me because I was expecting. Let's see if the keyboard is working here. Yeah, there we go. 16, and also here. 16, right? Okay, and then we can check our answer. And so yay, we got that one right? And then we can just move on to the next question. You don't have to do the questions in order, right? You can just skip around also. So don't have to do those in order, but that one's pretty easy. Oh, this one's a little bit trickier, right? We talked about this one last time. So minus 10 cubed, right? Okay. So we have a question, a little bit of a question here of the order of operations. We're going to talk a little bit more about that today, I hope. And what I mean by a question of the order of operations is does the cube come first there in that expression, or does the minus sign come first? What did we talk about last time? Yeah, the cube comes first, right? So you have to raise 10 to the 3rd power first, right? And then apply the minus sign to that, right? Instead of taking the whole quantity minus 10 and cubing it, all right? So 10 cubed is how much? 1,000, right? Okay. And then just apply a minus sign to that, so we get minus 1,000. All right, so let's imagine there that we messed up, right? And so we put minus 100, okay? And then that case, when we check our answer, it's going to tell us that we're wrong, right? Okay, and it'll try to give you some sort of hint sometimes about what you could have possibly done wrong, all right? Sometimes it's kind of accurate and sometimes not. So anyway, now we know that we did that wrong, okay? So you do get another chance, all right? So you will get multiple chances on this. I forgot how many chances you're going to get, though. Let's see. Let's keep answering it wrong. And what? 3. I see 3, right? Because this is our final chance, right? Okay? And so, darn it, we missed that one. But okay, MyMathLab is just so forgiving, all right, okay, because now you can go on to the next question, right, if you just don't remember how to do that, right, but you can also ask for a similar question, okay, so you can ask for a similar question and get another chance to get these points, right, okay, sometimes the similar question is the same, so you get really lucky, okay, of course we didn't know it the first time, right, so we get a chance to try this one again, right? Okay, and there we got it right. But most of the time when you ask for a similar question, it will change the question slightly. It'll be the same type of question, but it'll slightly change the question. Okay. All right. So there's an idea there of how MyMathLab homeworks work, and I think it updates your score constantly, so you don't have to worry about saving your work or anything like that. It's constantly in the background updating what you're doing, right? Okay. There are some question help options. Forgot what those were. So you can play with the help options, but one of them is ask my instructor. So if you want to ask me, you can click on that one and send me a question about that problem. I think it shows, well, I'm not sure now in MyMathLab, it may show me a copy of the problem and what you answered and what the correct answer was, right? So I can give you specific help, or it may not. So there's a thing you can try, or you can try view an example of that, or this is a step-by-step a series of instructions that give you help on that. So there are lots of help options in there are going to be lots of help options in MyMathLab. Okay, so you're going to find it easy to make, not completely trivial, okay, but you're going to find it much easier to make a really high score in MyMathLab than, for instance, you will on the test, right, where you don't have all the help and chances to answer questions again, right, and those sorts of things, right? So keep that in mind, okay? You really want to run your MyMathLab score, your homework score, really high, okay, because you can really control your grade in MyMathLab, okay, so you really have an opportunity to have that average, that score, your homework score, really high, and remember that contributes quite a percentage, right, to your final grade as given in the syllabus. So that's a part of your final grade that you can really control. You know, test scores, of course, you have some control over, depending on how well you prepare for the test, right? Okay, but you cannot completely control your test score, right? Okay, you know, things happen while you're taking the test. You get nervous. Some things you go blank on, right? Okay, you may make small mistakes, right? Small errors. But in MyMathLab, you really have a much greater control over your score, right? So take advantage of that. Take advantage of that opportunity. Okay, all right. So I think I said everything I need to say there. Did I say everything, Taylor? Okay, all right. So if you have questions, you can ask Taylor maybe after class or before class about specific things there in MyMathLab. Okay, let's get rid of that. All right, and now we're, I think, sort of ready here to finish what we were talking about last time, and then go on to some new things, okay, today. All right, so remember last time we were talking about rules for exponents, right? We were reviewing that. This is a real bugaboo for students in algebra classes, remembering how to simplify or evaluate expressions that have exponents in them, okay? And that is because not all of the rules for exponents are intuitive, okay? They're not all easy to remember. They're not all obvious why those rules are like they are. So they're easy to forget unless you practice them a lot, okay? And typically you won't between math classes, right? So they're easy to forget. So we're going to review again, or we started this last time reviewing these rules for exponents. All right, here is the last rule. We had practiced the other rules. Here's the last rule. And we're going to practice this one with a few more examples with your neighbors there. All right, so what this rule says is, it's written down in symbols here, but what it says is, you know, when you have a base raised to a fractional power, okay, but this can be any fraction, though, any fraction at all, as long as the fraction is reduced. That's one little catch there to this rule. The fraction has to be reduced, okay? So if it were the fraction, 2/4, you would have to reduce that to 1/2 this rule to be valid, okay? But if you have any base raised to a power, remember, fractional exponents mean roots, right? Fractional exponent means roots. So this fractional exponent also means a type of root. And the denominator there tells you the type of the root or the index of the root, right? So if that's a 2, it would be a square root. If that's a 3, it would be a cube root, and so forth, right? But the numerator of the fraction is going to stay as an exponent. It just remains as an exponent, okay? And you can put that exponent under the radical if that's convenient, or you can put it outside of the radical. I usually think it's easier to put it outside of the radical, okay? I find that to be simpler. But either way, so I should have put this first, because I think this is the easier way to simplify this expression. So notice that says take the nth root of a, right? And whatever you get there, just raise it to the m power, okay? So you have kind of a two-step process. Take a root and then raise it to a power. That's how you simplify. That's how you interpret these fractional exponents, okay? All right, so this becomes the index, right? This just stays as a power. All right. Well, you know, when you see that rule written down in symbolic form, right? It doesn't have a lot of meaning to it until we actually try it in some examples. So that's where we were at the end of class last time, right? We'd come to our last few problems here, and so so I want you, all right, to use that rule. Unfortunately, I can't display the rule at the same time, okay? So you're going to have to remember, if you didn't write it down, right, what the rule was, right? So when you have a fractional exponent, right, remember the denominator is the index of the root, right? And the numerator stays as a exponent, okay? The numerator stays as an exponent. So see now if you can, with your partners, right, or partner, write down for me the simplification for those four quantities, okay? And then we're going to get people to share their results with us, so everyone will have the right answer there, okay? So let's take just a few minutes. It won't take too long, okay? Well, let's start with the first two, because the second two are a little bit harder, all right, because they have negatives in them. So let's take the first two first, and then we'll worry about the negatives later, okay? So just I and J there to start with. That won't take too long. If you have a question, ask your partner, right? So make sure your answer agrees with whoever is next to you, sitting next to you, or whoever you've been working with, or whoever you're talking with. If you're new, just talk to whoever you're sitting with, okay? They'll be happy to talk to you. Or you can ask me, and you can ask Taylor too here. Oops. Where's Jennifer? That should be easy to remember. What'd y'all do with your cards? Furman, where's your card? Oh, right there. All right. So I already know you, Furman, but just to make it look artful, let's keep the card there. All right. Yeah, well, I think they're pretty onto it, but you can, yeah. Mm-hmm.
For this one, would it end up being like a fraction, like this?
Let's see. Yes, so what does negative tell you to do?
To take the reciprocal.
Take the reciprocal first, right? Okay. So, for instance, on this one, first thing you would do is take the reciprocal. So you would get 1 over 16 to the positive 3/2 power.
Oh, we're going to do that first. Not
Yeah.
take the square root?
I would get rid of the negative first, because the negative is a real complication, right? So get rid of the negative first. Yeah, okay. All right, let's look at, all right, y'all went pretty fast there, I think, okay? But if you didn't, that's fine, all right? We'll give you some help here. I'm going to ask someone actually to show us what they wrote down, okay? All right. So let me pick someone, at random here. I don't think I'm going to pick anyone I talked to last time, but I may have got the cards out of order. Nicolette, is Nicolette here? Where's Nicolette? Hi, Nicolette. Okay, so you have 16 to the 3/2 power. What did you get for 16 to the 3/2 power? Tell me very slowly so I can write this down for the class.
I put the square root of 64.
The square root, okay, of...
On the outside I put 2, and on the inside I put 64.
So here it's square root, right? And on here you put 64, but why did you put 64 there?
Oh, no, I meant to put 16.
Oh, 16.
Oh,
Oh, okay. Right, yeah. All right. Okay, so yeah. So it's square root of 16, and then what happens to the 3?
It goes on top of the 16.
Right. So did you put it here?
Yeah.
All right. So that makes it, to me, a little bit harder because you have to calculate now 16 cubed. Do you know what 16 cubed is? I'm not sure. That's not the way. I bet that's not the order you did it, Nicolette. Is that right? 1536. It's 1536. And then we have to try to compute the square root of 1536. Calculator will really help us with that. What is the square root of 1536 according to your calculator? Shall we try it here? Let me see if I can find a calculator. 1536, and then we want the square root of that. Whoops. All right, so someone told me something wrong there, okay? Let's see. What is 16 cubed? So 16 cubed... Oh, it's 4,096. That sounds better. All right. So 16 cubed was 4,096. And what's the square root of 4,096? 64, right. So we come up with the same answer, Nicolette. It is 64. Your answer is correct. But I bet you didn't do it in that order. What did you do?
I did not mean to do the 16 to the 3rd.
Yeah, that's right. Yeah, what you really meant was the 3 is outside of the square root, right? Okay, that's what I meant by it's usually easier if you put the exponent outside of the radical, right? Okay, because now all you have to do is take the square root of 16. Which is easy to do, right? That's 4, and then you have to cube 4, which is also pretty easy. So you also get 64 here, right? Okay. So see that order, although you get the same answer, so either way is really okay. Taking the square root of 16 first and then cubing it just makes it a little bit easier to do by hand. With a calculator, it's not really that much different, but by hand, it's easier to do with in that order, right? Okay. Well, but happy ending anyway there, Nicolette, because that is the right answer, 64. So you did that perfect. What about 27 to the 2/3 power? Let's see how that works. Skylar, where's Skylar? Is Skylar here? Is your Skylar? Okay. All right. So, Skylar, you're shaking your head. All right. So that means, all right. So that tells us that we're going to have to give Skylar there some assistance. All right. Did you help Skylar there? Is it Kevin? All right. Okay. So, who's next to them? Did you help them? Did you get it? Okay, you got it there, right? So, see, you need to, we need to be our brother's keeper here in this class, right? So if they are, well, okay, all right. So the moral is the same here, though, right? Okay, if you got it right, okay, and you need to help then your friends there, right? Okay, so they'll be ready for the test, all right? Okay, all right. So Skylar, we're gonna have to work through this now, okay, on the spot, all right? Okay. So we didn't meet Skylar last time, and we also didn't meet Nicolette either. Skylar, tell us about yourself first. Stand up, though, to do this.
go by Sky. I'm
Okay.
actually a biology major.
A biology major, excellent, right? Okay, so I know we have other biology majors in here.
Favorite genre of music is metal.
Metal,
I
okay.
like to read.
And you like to read. What's your favorite food?
I like burgers.
Burgers. All right. So those are all very common choices, right? Okay. All right. Sky. All right. So I'm going to get that right. Let's interpret the rule. Okay. All right. So Sky, help me with this. All right. So let's just try to repeat there, Sky, what Nicolette did in this problem because it's very similar, right? Okay. That's very similar. So what did Nicolette do in that previous problem when she was trying to interpret the... Hang on a second there. All right, so when she was trying to interpret the 2/3 power, what did Nicolette do with the 3 in the 2/3?
3 goes outside the square root.
Outside of the root, and what does it tell you about the root? It's a cube root, right? Okay, so the 3 tells you that you have a cube root. So let's write that down, that we have a cube root, right? Okay, so we have here cube root, right, of, and you keep the 27. Now what about the 2? We can't just drop the 2, Sky, so what happens to the 2? Goes on the outside, right, okay? The 2 goes on the outside. So we have here cube root of 27 squared. Now that's much easier to interpret, all right, okay? So first we just have to calculate what is the cube root of 27. So what is the cube root of 27? 3. Why? Okay, it is 3. Sky, why is it 3 though? So why did they give you the right answer? Perfect, right. 3 to the 3rd power is 27, okay? Right, so you knew that, right? And then all you have to do is square that, right? So what's 3 squared? 9, yeah. So, yay, right, okay? We got that. That's 9, see? So you can simplify that, all right? So when that shows up on a test, right, that's going to be an easy thing to do, okay? Or when it shows up in the homework, because it will show up in, it's going to show up in both places. Okay, let's try the next one now, all right, okay? So here, these are very similar, right? So you can probably rely on your answers from I and J, correct, okay, to get the answers for K and L, right, okay? So we can do those really quickly, right? Because those are very, I and K are very similar, right? And J and L are very similar, except just for the minus sign. So all we have to do is remember, right, what effect that minus sign in the exponent is having, right? Okay? So write those down for me really fast, right, based on our answers for I and J. Yeah, so what effect does the negative exponent have? We talked about this last time. What does that do? Okay. Okay, so that was pretty easy, right? Okay. Is it Tajani? Tajane. All right, so Tajane, what about K? What is our answer there? So what effect does that negative exponent have?
It would make the answer negative, but wouldn't it be the same as I, but it would just be negative?
Oh, so you're saying that it will be the same as I, right? Okay, but just because we have a minus exponent here, this becomes minus. So you're saying the answer there is minus 64. Okay, that's a very common mistake, but that is a mistake. All right, okay, but that is a mistake, right? Okay, and so this is a really crucial thing to remember about exponents. All right, and again, it's not intuitive, so it's something that's easy to forget. All right, Tajane. So it just takes practice to memorize it. Okay, but the sign of the exponent and the sign of the base, they do not interact with each other. Okay, so they are not related. So just because the exponent is negative, it doesn't mean your final result here is going to be negative. Okay, right? So that would be kind of a natural assumption. But it's just not correct. Okay, so see, that's kind of counterintuitive, and that's what's the tough thing about exponents sometimes. So what is the effect of negative exponents, though? So what is the key thing you have to remember when you're seeing a negative exponent? A fraction, right? Actually, a reciprocal. Okay, negative exponent means take the reciprocal. Take the reciprocal. Okay, so what 16 to the minus 3/2 power really stands for is 1 over 16 to the 3/2 power. Okay, see, negative exponent means take the reciprocal. Okay, and then you can change the sign of the exponent. All right, so now I can make that negative exponent positive after I take the reciprocal. All right, now, Tajane, it's easy because we already calculated 16 to the 3/2 power. What was that again? 64. So what you really get here is a positive number, 1 over 64, right, okay, 1 over 64. So I'm glad you said that, Tajane, because a lot of people are thinking the same thing because it's an easy misconception, right, okay, but it's one we want to get out of the way kind of fast, right? All right, so Tajane, what about 27 to the minus 2/3? We already know what 27 to the 2/3 is, right?
So it just be 1 over 9.
Perfect, 1 over 9, exactly. Yeah, okay. So 27 to the minus 2/3 power means 1 over 27 to the 2/3 power. So you can take the reciprocal and change the sign of the exponent from minus to positive. And then we already know that 27 to the 2/3 power is 9. So we end up there with 1/9. Okay. One place, where we use exponents a lot, okay, in science is in writing down really large or really small numbers, okay? So you've all seen this before. These last two examples here are examples of what's known as scientific notation, right? So that's just a method for expressing, really large numbers or really small numbers, which show up frequently in science classes, right? So like in chemistry, you're often dealing with really large values because you might have lots and lots of atoms, right, in a sample of a substance, correct, okay? Or sometimes in science, again, especially, you're dealing with really small numbers, all right? And so and exponents can really help us with expressing in an efficient form these really large or really small numbers. So what about, for instance, 9.3 times 10 to the 7th, okay? What is that number, if we write that out fully, what is that number really equal to? Well, that's 9.3 times, and then we just have to calculate 10 to the 7th power, right? What is 10 to the 7th power? Is that 10 million? Yeah, that's 10 million. So we end up here with 93 million. See, 93 million that's kind of awkward, right, to write out in standard form, correct, okay? In decimal form because you get so many zeros there, right? Okay, so scientific notation, that is making use of exponents, right? That gives us a chance to write the number down in a little bit more efficient form. This big number comes from, this is an astronomical distance, okay? And astronomical distances are often quite large, right? This is the distance from the Earth to the Sun, so that's a really big number. And I'm not sure what this number is, okay, or what it represents, but we can figure out what that is, right, okay? So this is 5.89 times 10 to the minus 6. So what is 10 to the minus 6? So again, how do we interpret that negative exponent? Well, but yeah, that's what ultimately what's going to happen there, right? But first, let's just calculate this. What's 10 to the minus 6th? That's 1 over 10 to the 6th, right? Okay, which is 1 million. So you have 5.98 times. See, and it gets really awkward to write this out, right? 1 over, I can't even fit all the zeros in there. It's supposed to be 6 zeros. So you have 5.89 times 1 millionth, okay? That ends up being, I think, 0.000000589, okay? So a really small number there, right? Okay? And it's awkward to write out that small number because you have to write all those decimal places correct. So it's kind of more efficient to express that number in with using this negative exponent, right? Okay. So there's just one application of exponents, right, where they really come in convenient, including negative exponents, right, where they really come in convenient for us in science. Okay. All right, I'm going to ask y'all here's kind of our last a question here about exponents. All right, so suppose we wanted to estimate this number, the fifth root of 250, okay? The fifth root of 250. That's really awkward, right? Because we're not used to calculating fifth roots very often, correct? Okay? And the fifth 250 is not a perfect fifth power, so this is not going to come out as a whole number. The fifth root of 250 is not going to be a whole number, okay? So if we wanted to estimate that, what could we do? Well, obviously, we're going to have to resort to what? I think. No, that's trying to simplify by hand, okay? But here we're just trying to estimate what is this number, just as an estimate. What is the fifth root of 250? How big is that, okay? We might get really crude estimates here. We might be able to get really crude estimates for the fifth root of 250. I can give you a really crude estimate because what is 2 to the fifth power? That's 32, right, okay? But if you go up and raise 3 to the fifth power, you get what? That's 243, okay? So that's 243. Notice that's a little bit below 250, right? Okay? But on the other hand, what is 4 to the fifth power? That's 1,024, right? Okay, so we know here then that the fifth root of 250 has to fall between what two numbers there? 3 and 4, right? Okay, so it's somewhere between 3 and 4. So it's got to be bigger than 3, right? Because 3 to the fifth power is 243. But it's going to be definitely less than 4, right? Okay, because 4 to the fifth power is already really big. That's 1,024. So I know it's between 3 and 4, so it's some decimal value there between 3 and 4, right? Okay, but that's not a very good estimate. You know, if I just say, well, it's somewhere between 3 and 4, right? That's not very accurate. So if we wanted to get a more accurate estimate, in particular, if we want to get 1 to 3 decimal places, we're probably going to have to resort to using what? Montel, any idea what you might try there? Ooh, earbuds. Naughty. Okay, so take those out and put those away. All right.
Could you ask that again?
Yeah. What would you have to resort to use the fifth root of, to find the fifth root of 250?
First, you would have to go through the fourth one, or third or fourth. And how you would go about it.
Montel, come on. What would you do? What would you use? Calculator, right, okay? You're somehow going to have to resort to using your calculator, right, okay? How else are you going to get an estimate there for the fifth root of 250, right, okay? You're going to, especially to 3 decimal places, correct, right? So you're going to have to somehow rely on your calculator, right, okay, to try to get that estimate, all right? Now, but the question is, how do we use the calculator even to get the fifth root of 250, okay? How do we even go about doing that, okay? Because calculators frequently have square root keys on them, right, okay? So that's pretty common. They have cube root keys on them usually, right, okay? That's pretty common, right, okay? But it's more unusual for calculators to have fifth root keys on them, okay? That's not very common, all right? So typically we don't have fifth root keys on calculators, right? So even with the calculator, right, we have a little bit of an issue here of how we're going to estimate there that fifth root of 250. This is where fractional exponents, though, really help you, okay? This is where a fractional exponent, Montel, can really help you. Because how can you rewrite that fifth root of 250 as an exponent? So the fifth root of 250, if we wanted to write that as an exponent, what would that look like? So I want to write that not as a root, okay, but I want to write that as an exponent. Yeah.
250, and then the exponent's going to be 1 over 5.
1 over 5, perfect, right. Yeah, the exponent there would be 1/5, correct? Okay, so this would just be 250 to the 1/5 power, right? Okay, yeah, 250 to the 1/5 power. And 1/5, that's easy to write that as a decimal. How do you write 1/5 as a decimal? What is that? 0.2, right, okay? So we can rewrite this 250, the fifth root of 250, as 250 to the 0.2 power, or 0.20 power if you like, okay? So that's another way of expressing the fifth root of 250. Now, the reason that's helpful is because it's very easy on calculators to raise numbers to powers, okay? All calculators, all scientific calculators will have a key that will allow you to raise a number to a power, okay? It may vary from calculator to calculator a little bit, okay, on what the key is, all right? So on some of the older calculators, you might have a key that looks like this. So it might say on it x to the y power, okay? Or it could be, sometimes it's backwards. You might see y to the x power, all right? And then we just want to take 250 and raise it to the 0.2 power, right? That's the same thing as the fifth root of 250. Let me see what since I can show that here, let me see what the Windows calculator says we would do with this. Okay, so there's the Windows calculator. This is kind of old-fashioned, all right? But there we have 250, right? And notice, let's see, does it have a nice here? I hope so. There it is. See? Oops, I didn't type it in right, though. So there's 250, and there, let me try that again. So there is 250, and see, there's that x to the y power key, right? Okay? And then we can just type in 0.2. And, oh, there it is, okay? So there's an estimate for the fifth root of 250. Let's see, if we round that to 3 decimal places, what is that? 3.01, is that going to be an 8 there? No, a 1, right? Oh, no, just 3.017, right? So approximately to 3 decimal places, we get 3.017, okay? Now, on some calculators, though, so particularly on graphing calculators, you might, well, there are different things. You also might have a caret key, okay? And the caret key is often used to represent a power, okay? So on your calculator, you might have a caret there instead of an x to the y key, and you can also use that to raise 250 there to the 0.2 power, okay? Of course, you'll get the same result, right? Either way, all right? So depending on the model of your calculator, this is how you can estimate the fifth root of 250, right? Okay, that's by using fractional exponents again, okay? All right, let's try something else now here for fun that's kind of related to simplifying these exponents, but slightly different. Okay, so one instruction, I've already mentioned it several times in this class, but it's common in any math class. One instruction you'll often hear is to simplify an expression. So, the instructions for a problem will say simplify. Simplify this expression, all right? And the problem with that term is it's a little bit ambiguous, okay? In different situations, simplify means different things, okay? So to mathematicians, when we're speaking to each other, when someone says simplify something, it depends on the context, but we'll know immediately what the other person is telling us to do, right? Okay, but that's for a trained mathematician, right? So if you're just a student, right, and the teacher tells you, oh, simplify something, that sometimes can be confusing what they're actually telling you to do, all right? Because it can mean different things in different classes. So in this class, when I'm talking about simplifying an expression, right, what I mean is I want you to carry out all of the operations that you can, the arithmetic operations that you can, in that expression as much as you can by hand, all right, by hand, without resorting to an estimate, okay? You can use a calculator. I didn't say you don't have to use a calculator, right? But you don't want to resort to a decimal estimate, all right? So it's doing as much of the math as you can without having to get an estimate, okay? That's what I mean by simplify, all right? So when you've reached a point where you can't carry out the math operations in the expression by hand any further, then that's where you would stop, okay? That's the end of the simplification. Now, in most cases, that's pretty easy to do, all right? Okay, you may have to have a calculator help you, raise powers or do multiplication or do division sometimes, okay? That's fine. But most of the time, when people are simplifying expressions, they'll come out with the same answer, all right? And there's no question about that. But there are some weird situations, okay? And so we have to talk about those. Here's one that has become really famous lately, just in the past couple of weeks, all right? Because this has been going around the internet as kind of a viral question on the internet, all right? I took this question from I took that picture from a Twitter posting, okay? All right? And you can see what the question is. It's, what is this expression equal to? So, in other words, how does one simplify this expression? So, simplify again means what? What are we going to do? Yeah, we're going to... Well, no, you can have a calculator help you, right? Okay, but without resorting to an estimate. You don't want to, without having to give a decimal estimate, right? See, for instance, the fifth root of 250, we wrote down 3.017. That's a decimal estimate, right? Okay, but without having to resort to a decimal estimate, carry out the math that you can by hand. All right? Okay, so that's what I want y'all to do with this expression. I want you to simplify it for me, okay? So simplify that, and let's see what answers we get, okay? So y'all might be a little bit smarter than the average person reading Twitter because you got lots of different answers to this question. It caused all sorts of controversy on Twitter about what the correct simplification was, all right? Of course, we want to have one correct answer in here so we're not all getting different answers. So we'll talk about what I consider the correct simplification, all right? All right, so, but you can talk with your partner about this, okay? What is that reduced to? So all of these you can do by hand, right? All these operations you can do by hand. So you don't really need the calculator at all to help you with this one, right? Okay. What'd y'all get there?
I got one.
1, okay.
I'm stuck between 1 and 16.
You're stuck between 1 and 16, okay? So you got to make a choice there, all right? So which one is it? What'd you get there? You choose 1, okay? All right. Oh, so y'all have a debate there, all right? You can't have 2 answers, right? Because there can only be 1 answer, right?
I don't know.
Okay, all right. Okay, there's a New York Times article actually about this question, and in the headline of the article it says the answer is not 100. So I will give you that. The answer is not 100, so don't get 100 because that's not. You thought it was 100? I guess, because that's in the headline, right? The answer is not 100. I didn't read the whole article, though, so I don't know. So you can eliminate 100 as a possible answer there. All right, let's see what we got. Okay, most people already have an answer there. So how many answered 1? Raise your hand there for me, okay? So about half the class. How many answered something different? What was the other common answer? 16, okay. How many put 16 there? All right, okay. Did we get something else other than 1 or 16? Did someone get something else there as a candidate? Let's write. I want to write these down. So we got a 1, that frequent. We got 16. Anything else? Don't be shy now if you got an answer because it might be the right one, right? Okay, so that was it. Only one of those 2. Okay. All right. So let's talk about how one actually does simplify this, okay? So what's the, for those people that were stuck with, that were saying, I don't know, I have 2 possibilities here, what seems to be the question? What led to that confusion about the answer? Yeah.
There's the problem, sorry, I have to it's like after you do what's inside the parentheses, so do you start left to right, or do you just like multiply the 2 by the 4?
Oh, I see. So, so did most people go ahead and start with adding 2 and 2 together there inside the parentheses? Did anybody do something different there? Okay. So started there, and then we came to, then you come to this, right? So you have 8 divided by 2, then times 4, and then what's the confusion at that point?
Like you start left to right, or if you do 2 times 4, like is it 8 divided by 2, or is it 2 times 4?
All right, so it's which of those operations there do we want to carry out first, right? Okay, do we want to do the division or do we want to do the multiplication? And that's exactly the issue with simplifying expressions, okay? It's the order in which we're going to carry out the operations in the expression, right? That's what leads to all of the ambiguity about simplifying expressions, right? Okay, in which order do we do that, all right? So look, to resolve these sorts of disputes, right, mathematicians have developed standard orders of carrying out operations. unfortunately, there's more than one of those, all right, okay? So there are sort of different standards that people follow, okay, in different situations. But we're going to follow a particular one that is certainly the most common one, right, okay? And so, and you're probably familiar with that, but I want to remind you of that, right, okay? So here is the standard there, order of operations, right, okay, when you're trying to simplify an expression, all right? So you always work inside grouping symbols first, right? So you're going to do parentheses, okay? So y'all did that right. You want to work inside parentheses first. That was great, okay? And then next, exponents. So if you have exponents, you want to carry the exponents out next, but we didn't have any exponents in that expression, thank goodness, right, okay? Next is multiplication and division. But they have the same order, all right? So it's not multiplication before division, all right? It's not multiplication before division. They have the same precedence. That's because multiplication and division are really the same operation, right? Okay? They're really the same operation. So they really have the same precedence. Well, this is going to cause an issue, right? Okay? Like it does in this problem. If you have a multiplication and division to do, then, right, which comes first if they have the same precedence? The answer is typically we proceed from left to right, okay? But there are different versions of the order of operations where you follow different rules, but this is the one we're going to follow. We're just going to proceed from left to right, okay? And then next, final, lowest precedence is addition and subtraction. Again, they have the same precedence, so you proceed from left to right, okay? All right, so in our order of operations, what was the right order there? Or what's the right simplification? 16, right, okay? Because we would divide 8 by 2 first, okay? That would give us 4, and then multiply in the 4. So we would come up with 16 and not 1, okay? All right, now if you came up with 1, that's not the end of the world, all right, okay? But unfortunately, it would cost you points on a test, so you have to be careful about that, okay? Just as a reminder of how you remember order of operations, right, okay, you can turn that order into an acronym. An acronym means you take the first letter of each word out of the phrase, right? So if you take the first letter of all those operations in the order of operations, you get PEMDAS, all right? So if you can remember that word PEMDAS, that will clue you in on the order of operations, okay? So write that down. That's sometimes helpful for remembering the order of operations. But PEMDAS is not an English word, right? So I don't think so. We can look them in the dictionary, but I don't think there's PEMDAS, right? Okay. So sometimes an acronym can help, a mnemonic device, a little memory device can help you remember this too. And so the memory device everyone always learns for order of operations is, please excuse my dear Aunt Sally, right? Okay, where we take that acronym and then attach it to an easier to remember word, right? Okay, or an easy to remember phrase. So please excuse my dear Aunt Sally. That also is a reminder there of what is the correct order of operations. Most of you now, I think, know the precedence of the order of operations, but what you probably forgot was you want to proceed from left to right, okay, with multiplication and division and addition and subtraction, at least for our class, okay? Now, when you get to a computer science class, they may tell you something different, all right? Then you can argue with them about that, okay? But for our class, this is how we're going to go. Yeah?
And you mean that left to right in an equation, not PEMDAS, the actual acronym. You mean you want to follow
Right.
order of operations in the equation.
Yeah.
So division from the front to the left. You start with the order and then...
That brings up, yeah, right. Yeah, okay. That brings up now another point, though, that I have to make that in the class, all right, and you keep saying, which is fine, okay, you say equation, all right, but we have to be careful here about distinguishing between expressions and equations, okay? So, for instance, this is an expression because that's just a collection of numbers and operations, you can also include variables. So any collection of numbers, variables, and operations, that's an expression. All right? So I would call that an expression. An equation is a particular type of expression, though. Okay? An equation is an expression that contains an equal mark. All right? So if the original expression does not contain an equal mark, it's not an equation. And I'm going to be real careful about distinguishing between the two, okay? But most people don't. Most people would call that an equation, but it's really not. It's just an expression because it doesn't have already an equal mark in it, all right? So when I say simplify this expression, notice no equal marks there, okay? Now, you'll probably turn it into an equation really quickly because in simplifying it, you'll start putting equal signs, all right, okay? But initially, it's just an expression, all right? Now, these two expressions have variables in them, okay? Not all numbers, but we can still talk about simplifying those expressions, and it still means the same thing. It means carry out all the operations that you can by hand, right? Okay, before you get stuck, all right? Before you cannot proceed any further. All right, so I want you to simplify these two expressions for me, okay? I want you to simplify those last two expressions for me. We won't work on the first two examples, but the last two expressions, oops, let me write those down. I want you to simplify those, okay? So carry out all the arithmetic you can in those expressions as far as you can until you cannot do anything else, okay? So do you remember how to simplify those expressions? You've simplified those before, so, or things like that. So Montel, you should be writing, right? Okay. Okay, but not on there because we're using that for something else. Don't you have some more paper? Huh? Yeah, just the bottom two, C and D. Okay? We may warm up next time with A and B. The first two are just kind of arithmetic, so the last two are more algebraic, right, because they have variables in them. Of course, this is an algebra class, so those are probably more important to us in the long run than the first two. Remember how to do that, Ben? Okay, yeah. Yeah, Joshua, how does that one work? You don't remember any of them? Oh, wow. So it's a good thing we reviewed this. You go as far as you can without using decimals, right? So,
Okay, so that, and then I could actually simplify this to that.
so you wouldn't. What did you come up with there?
7 over -2.
Yeah. So in our description of simplified, that's where you would stop. Of course, that one you can really actually calculate. It's minus 3.5, right? So if you took that one step further, it would be okay also. But you could quit right there, all right?
Okay.
But I'll give you a hint. You did it wrong.
Oh.
Yeah. Okay. It does come out to be a whole number. Did y'all get something there?
I have this answer, but
You had that answer? What about the second one?
right here.
You got that?
Yes, sir.
Okay. All right. So you do have something.
I
You're saying I have something,
but
but. Huh?
I have something, but I don't know if it's right.
Well, so you should compare with him, right? Okay? Because, and have him show you what he did, right? Okay?
No, but I need your input.
That makes sense.
Let's write down. I see. Looks like it could be right.
With that one,
Hmm?
that's as far as I could go because I broke it down into two
Mhm.
exponents, fives.
Yeah, that's just, I think by hand that's as far as you can go, right? There's nothing else you can do here until you have a value for x, right? Okay. Here you could go a little bit further because these two terms can be combined, right? Okay. But here,
Wait.
that's it, right? So that is fully simplified. I can't do anything else by hand, right? Until I have a value to substitute for x, right?
In the calculator, like find x or something like that.
Well, you need something to substitute for x, right? Okay. Otherwise,
Yeah, but that's as
Right.
far as we can go.
that's right. That's as far as you can go by hand. That is simplified. Yeah. Okay. Right.
Oh, I don't know if it is.
Excuse me.
Mhm.
This equation, this expression, right?
Mhm.
Okay.
Is that right? Oh, I'm not sure. I don't know what the answer is yet. Okay.
No? You don't look at them before you put them up?
Well, I sort of have an idea, but I didn't do it out all the way. Yeah. Okay. Did you get something here?
Yeah, I just have wrong and I wrote it again.
Oh, okay. All right. These look pretty good. So we're remembering well there. Did you remember it, Ben?
I remember D. That's
You remember this one, but you don't remember the other one?
No.
Oh, okay. Well, she can tell you though, right? Okay. So you should ask her, right? That's what friends are for, right? Okay. Did you get the first one?
I got stuck right here.
Oh no, I mean on just C.
Oh.
Does
I
that
have
look real? Okay, that one looks really hard. Did you get C?
No, sir. I got D.
Oh, you got D. Okay, but not C.
No, I'm working on it now.
Okay, you're working on it. Did you get both of them?
I only got D. I can't remember C right now, but that's what I got for D.
Yeah. So the trick to C is really do the same. You did the same thing here. Okay. You have to multiply everything here by everything here. So x by everything and 2 by everything. See, that's what you did here, right?
Yeah.
You multiplied by x and 5. You do the same thing there.
Okay.
Okay. Yeah. So you end up with a lot more multiplications there. All right. So Sky, that looks. I'm not sure what the answer is, but that looks right. And this one I know is right. Okay. So that's good. Salma. Okay. Oops. Did you get him, Salma? Okay, so, all right. Let's look at those in a second. Did you write something down there?
Yes, sir. Right here.
Oh, right here? Okay. All right, what about for C? Oh, this one?
This one, C.
Oh, okay. All right, I see. All right. All right. How'd you go from here to here? Is that one this one?
It's this one. Oh, it's because I added them.
You added what? Oh, you added these two? But you forgot this, right? That should be still there, right? Okay. Okay. All right. Let's. All right. So most people have parts of this one. So let's ask someone. Now this one might be a little bit tougher to show because I may have to have you come up here. All right. So you may have to be the first guinea pig of coming up. Uni, where's Uni? Uni, Uni. Okay, all right, Uni. All right. All right. So y'all are gonna. Can you come up and show us your?
Us together, yeah.
You want to go together?
Oh no, go ahead.
No, they can go together if y'all are partners. If you feel like you okay, if you feel like you need moral support, that's fine. Okay. All right. Okay. All right. So yeah, that's right. You're gonna come. Yeah, you're not actually gonna do it on the board. Yeah, you're just gonna bring your notebook because we're gonna show it on the dot cam. Okay. So this is just C. Let's just look at C and just simplifying that one. So that looks all right. So explain there, Uni, what you did.
So first, we got this x, and we multiplied it times x squared.
Mm-hmm.
And then we got x3.
Right.
And then we did x again, and we multiplied that times 3x.
Mm-hmm.
And then 3x squared.
Right.
And then we did 2 times 2x, I think. And then 6x.
You did 2 times what?
It's a long explanation.
It is a long explanation, but so you did x times x squared, x times 3x. You're not quite through with the x, though, are you, Uni? Because you didn't multiply x by what?
Oh, you're right. The 6.
The 6, right. Yeah. Now you multiplied the x by the 6, and that gave you what?
6x.
There's where the 6x came from,
Yes.
right? Okay, yeah, right. Okay. So just to summarize that, right, you took first the x and multiplied it by everything in the second set of parentheses, right? Okay? Yeah.
Yes.
All right. Now, then what?
And then the same, but with the 2.
The 2, right. So you took the 2 and multiplied it by everything, right? So that gave us what? 2x squared plus 6x plus 12, right, okay. So see, now the multiplication is done, right? So she's done the multiplication. So you did that in the right order, actually. I forgot to mention order of operations. But remember, first you're going to work inside parentheses, but there's nothing you can do in the parentheses, right? So now you do the multiplication, which you just did for us, okay? All right. The way you carried out, by the way, this process that you use, that's called the distributive property. That's how you were actually able to carry out the multiplication. All right. Now what?
Now you combine everything.
You combine things, right? So what did you combine?
The x3. What about
The x3, but there's nothing to combine with x3, right? So you just end up with the x3. Now what next, Uni, did you combine?
The 3 and the 2.
Yeah, the 3x squared and the 2x squared, right? And that gave you what?
5x squared.
5x squared. And then what?
The 6x plus 6x.
Gave us 12x, right? And then you just have the 12.
Yes.
That's it, right? Well, you just explained that perfectly. You shouldn't have been nervous about that at all, right?
I wasn't nervous.
Okay, I'm sorry. All right, so so there you are, right? So that is simplified now because Uni cannot do anything else with this expression by hand. Until we have a value for x, there's nothing else we can do here. There's no other arithmetic we can carry out, right? Okay, so that's what I mean by simplified. You're nothing else to do there, okay? Perfect, all right? So that's great. All right, Uni, all right, so let's do the last one. So let me ask for Emily. Emily, is Emily here? Cardozo? Okay, Emily. So show us x, what is it? Minus 5 squared, okay? You want somebody to come with you for moral support? Okay, so someone come up with Emily for moral support there. Furman, will you come with her? Okay, all right. Y'all are doing so beautifully. You don't need to. Y'all don't need to be shy. Okay, so show us what you did there on x minus 5 quantity squared. Just set that down there for us.
It's because we haven't done
Okay, all right. All right, so scoot it over there so you can put it in the... All right. So, I see two things written down there here, okay? So, first you wrote x minus 5 squared, and I noticed you wrote x squared plus 25. So how did you get that?
It's wrong.
It's wrong, right? It is wrong, but how did you get that?
Just did by the multiplying the power by 2.
So you just raised everything to the second power, right, okay? That is a common mistake, all right? A very common mistake when you're squaring quantities like this one is to just take this and square it and take this and square it, okay? That, by the way, is called freshman's dream. That mistake is so common, all right? So I'm glad to see that as a mistake, believe it or not, all right, because we can point that out. X squared plus 25, not the right answer, okay? All right, so, but Emily and Furman, how do we really do this now? So how do you really square x minus 5?
Well, you actually separate the exponent, so it's really 2 parentheses of x minus 5.
Yeah, you expand that, right? So you write the x minus 5 squared. You have to remind yourself, oh, when I square a quantity, that means I'm multiplying it by itself, right? So you write it down as x minus 5 times x minus 5. And now what happens? Well, you don't have to call it anything. Just explain what you did.
So you multiply 5 x times x.
Yeah.
And then x times negative 5.
Right.
And negative 5 times x.
Perfect.
Negative 5 by 5.
Right. So we got x squared minus 5x plus 25, because minus 5 times minus 5 is plus 25. And now you got one more step. What else can we do here? There's one more thing you can do by hand.
Yeah. Taking out the 2 5. No, wait. It will become negative 10.
Right. So write that down for me there at the end. Yeah, so the whole thing is what? So there you go. Perfect. There's the answer there. X squared minus 10x plus 25. Did y'all get that? X squared minus 10x plus 25? Yay. Okay, right. That's the correct way of squaring that. Oh, wait a minute. So what's your question?
Wouldn't you have to put them in order from smallest to biggest, so like x, then x squared, then the regular number left?
No. All those terms are added and subtracted, right? Okay. Let me show that. So Montel's asking, are we supposed to write the terms in a different order? And the answer is, I guess you could, but all these quantities are added or subtracted from one another. And remember, that it can be rearranged in any way. Addition, it works in either order, right? Okay. So you can write those quantities down however, all right? It's going to be the same. Now, there might be a preferred order, okay, in which you want to write them down. Not necessary, but preferred. We'll talk about that maybe later. If there's a preferred order, we want to write down these quantities, okay? All right, so you got that perfect, though. That's great. See? Excellent. All right, so there's a little bit of review of a couple of things that catch students up, right? Exponents and order of operations. I'm glad we went through that because we caught a few mistakes that I don't want you making in the course. I hope this will help you avoid those common mistakes. And it also gave us a little chance to talk about algebraic terminology and get our algebra, again, as I mentioned, neurons here sort of loosened up and working again, right? Because we're going to switch gears a little bit, just a little bit, before we get back to algebra. We're going to talk a little bit about data, okay? So it may seem like data and algebra are kind of unrelated to one another, but we're going to see that they're really not, okay, because we're going to make a relationship between these two ideas. So let me give you a little set of data here, okay? And this is called one variable data, because all we've done is we've observed a value multiple times, okay? Just observed a value multiple times, and the value is varying, it's changing, right? So when we observe it at different times, we get maybe a different value for that observation, okay? And I'm just going to write down those values that I get in a list, okay? All right? So here's an example of a one variable set of data. What I've done is I've observed the average temperature, the average yearly temperature, okay, at 15, I think it's 15, isn't it? Yeah, 15 random locations here on the Earth, okay? So I've just selected 15 locations at random on the globe, okay? And I observed at that location what was the average temperature over the year. In this case, it was the year 2017 at that particular location. All right, and we measured temperatures like we often do in science. And this is measured in centigrade. Okay, which for Americans makes those temperatures a little bit hard to interpret. You know how really hot or cold that temperature is, right? But for people in other countries, that's very easy to understand the meaning of that temperature, right? All right. So again, this is just 15 random temperatures, right? 15 average temperatures measured at random locations, okay? So again, you just have this list of data values. They are related in the sense, though, that we've measured the same quantity over and over again, right? The quantity that we're measuring is the average temperature, all right? But we've measured that multiple times because we measured that average temperature at different locations. So we get different measurements, right? Because at different locations, the average temperature for the year is going to be different, correct? Okay, especially since we chose these locations at random, right? Now, if you were asked to somehow summarize or analyze that set of data, right, okay, to try to draw meaning from that set of data or try to give a description of that set of data, what could you do to kind of describe for someone that sort of what that data is telling you, right, without having to actually, go one by one through all 15 of the data values, right? So how can you summarize those 15 data values? What sort of things could you do to describe for someone quickly, right, briefly, what that data looks like, for instance, okay, quote unquote looks like, right, okay? What are some of the things you could do? So you can make a graph, right, okay, of that set of data, okay? What else? What now? Well, graph chart, right, okay? So somehow make a picture of the data, right, okay? That's really good, all right? So somehow make a picture of the data. And there are lots of different pictures we could draw with this data, okay? So make a picture of the data. That's nice. What else?
Could we, well, I don't know if this would be right, but could we, like, do something like that?
What are you trying to picture there? Oh, you're showing me the minimum and the maximum?
And then, well, I'm trying to, like, the X, like, there are temperatures that are between it.
Right. So she wrote down, what she wrote down here was this expression, which, by the way, is called an inequality expression, right? Not an equation. And what she's saying in that expression is that the minimum temperature, right, in this set was 13.5. Is that correct? Right? Okay. And the maximum was 15.5. Is that correct? Do I see a 15.5? Oh, yeah, right there, right? Okay. So actually, we should say greater than or equal to here and less than or equal to there, right? Because you do have a 15.5 in the list, and you also have a 13.5 in the list, right? Yeah, so there's one. Another one, we had two, right? Okay, there's our second one. You could just simply say, oh, the minimum was 13.5, and the maximum was 15.5, right? And that gives someone an idea of kind of what the data set looks like, right, without having to write down all 15 data values. It's not a perfect description of the data, right, but it's some way of describing the data. So I like that, okay? And I like the picture idea too, okay? That's really good. So you could say the minimum was 13.5, right? Okay, and the maximum was 15.5, right? Okay, what else? The average, right, okay? I was waiting for y'all to say that, right, okay? Yeah, there's a very common way, right, of summarizing a set of data, right, okay, is by taking the average, right, okay? So we can average up these 15 data values, and the average there turns out to be, I think, 14.6, okay? So Montel, I did calculate that beforehand, all right, okay, because I thought someone was going to say average, and I didn't want to have to go through all the steps here of computing the average, all right? So I think the average is 14.6. Can you think of something else we could say about some way of summarizing that data? You might also say, oh, the range of data, it's kind of related to the minimum and the maximum here. You might say the range, that's the difference between the smallest and the largest is, what's the difference between the smallest and the largest one here? 2, right, okay? So there's another common way of summarizing those, 2, right, okay, of those 15 data values, all right? There are lots of others, though, okay, many other ways of describing that set of data values, and that study of those different ways of representing or analyzing that set of data, that's taken up in statistics, okay? That's one of the key branches of statistics, all right, is learning how to summarize or describe a set of data like this one. This is a very important, though, this is a very important value that you can derive from that set of data, okay? Because these 15 data values were taken at random places across the globe. So what does that average sort of mean to us there? Yeah, that's sort of the average global temperature across the entire planet, okay, in 2017. It actually, the more accurate value is actually 14.7. Okay, so this average of these 15 data values is actually very close to the more accurate estimate, which now is 14.7. Okay. And that's a very important number that scientists study quite frequently, right? Okay, what's the average temperature across all locations there on the planet, okay? I think 14.6 or 7 is about 57 degrees, so the average global temperature is about 57 degrees. That means at all locations, at all times of the year, altogether averages about 57 degrees, okay? Of course, why is this quantity important to us? Well, that we're going to consider in this table of data, all right? Now, this table of data is different, okay, because it's still a set of data, but this is called two-variable data, all right? Because notice in this set of data we have two lists of numbers, right? Okay. Now, of course, the numbers are related to each other, all right? Because here what we've done is we've observed the average global temperature, which in 2017 was 14.7, okay? We've observed that for different years, okay? In fact, here's every 10 years since 1880, okay? Here is the average global temperature given to us in centigrade, all right? So this is called two-variable data because we have two related data values here. The average global temperature and the year then in which that average global temperature was observed, okay? So for 1880 it was 13.8, 1890 it was 13.5, and so on and so forth, all right? of course, what's concerning to us and to scientists, right, is you can see sort of quickly from the data there, of course, what's been happening to our average global temperature. Yeah, that's right. It's been increasing, okay? So that average global temperature we can see has been increasing. Of course, that phenomenon is known as what? That's known as global warming, right, okay? So there is our table there, which kind of indicates, right, global warming. Okay, all right, so we want to ask the same question that I did about that one variable set of data. So you understand two variable set of data, right, is you have a set of data pairs, okay? Instead of just a single data value, you have a set of data pairs in your set of data, right, okay? So you have pairs of numbers that are sort of matched in some way. In this case, we got a pair of numbers by observing the same value, right, at different times, right, okay? So this is called two variable data. We get from that a set of data pairs. All right, now the question that I want to pose for you next time, so we'll have to take this up at the beginning of class next time, is how can we describe a set of data pairs, all right? So if we wanted to summarize and describe a set of data pairs, how could we do that, okay? Right, okay? What could we do to summarize a set of data pairs, all right? That's the first thing we're going to talk about next time. Actually, I'm going to let y'all tell me how you can summarize a set of data pairs. So hang on to this sheet because we're going to use it next time. So be sure you bring it back, okay? Be sure you bring it back with you, right, okay? Because I don't want to make more copies of that, okay? Killing trees contributes to global warming, by the way, so I don't want to make more of those copies than I have to, okay? Yes? That's just that question, yeah, and it's totally open-ended. You do it on the back, yeah, and it's totally open-ended. It's how you want to describe it, right? So how can you think of, how could I summarize that set of data?
So summarize not like in words, but like...
In words, in any way you want, okay? Right, so think of making a report on this. How could you briefly summarize that instead of just saying, look at the table, okay? How could you summarize it in a nice, efficient way for the class? I'll see y'all Monday.